So part of the reason we've been practicing these is so that now you can evaluate expressions like this without your calculator. Mental math. 3 log 9 of 6 minus log 9 of 72. Does that look like mental math? Looks more like a headache. So we'll use those log laws, simplify it down, and then see if we can evaluate it. So our first goal is, can we get this written as a single log? And if I'm going to write this as a single log, well, anytime I have a number in front, we're going to do that power rule first. So I'm going to have log base 9 of 6 cubed minus log base 9 of 72. And now I'm going to subtract. Now, if you remember that 6 cubed is 216, you can write that down. I would actually, if I'm doing this without a calculator, making numbers bigger always makes them harder to work with. Having them factored will make them easier to simplify. So I'm going to keep 6 cubed the way that it is. Now that I'm subtracting, I can write this as log base 9 of 6 cubed divided by 72. Well, we have to evaluate, so the part of evaluate means you have to get a final answer, just a number. So if you left it like this, you haven't evaluated yet. You've simplified, but the reason I kept it as 6 cubed is hopefully I could simplify this fraction. Yes? 72 is what?
26 squared divided by 2 is 36.
Right, so we've got 72 is 2 times 36. And so we can write the top, I'm going to write a 6 times 6 times 6 in expanded form. And if I have 2 times 36, and 36 is 6 times 6, we can break it up that way. And that makes simplifying your fraction easier. Whereas if I had 216 over 72, you could break it, divide by 2, and then divide by 2 again, and divide by 2, and divide by 3, and it would just take longer. So this is a faster way of simplifying it. And so in the end, I get log 9 of 3. And I still need to evaluate. But now that I've got it as single log, I can say to myself, again, maybe my log laws, I'm not there yet where I can just figure this out in my head. But I can say, I don't know what this is equal to, so I can make it equal to x. And I can change it from log form back to exponential form, something I'm more comfortable with. The base is 9. Log solve for exponents, so the exponent is x, is equal to 3. And so far, when we're solving for exponents, our strategy has been, can you get the bases the same? And we go back to our powers chart, and we say, are 3 and 9 in the same thing of our powers chart? And they are, because 9 is 3 squared. So I'm going to change my 9 to 3 squared. Of course, this 3 on this side is 3 to the 1. Use our exponent law to multiply, so I get 3 to the 2x equals 1. And now that my bases are the same, these exponents have to be the same. So I get x is a half. Mental math-wise, can you see that? 9 to the half is 3. How good are you at doing your powers to a half? Because the powers of a half are the same as square roots. So one of the things you're going to be looking for with powers is putting in square roots and cube roots as answers for mental math kind of situations like this. And go, oh, the square root of 9 is 3. So 9 to the half is 3. And maybe you'll be able to do it right from here. Because remember, at this step, what we're doing when we're saying log base 9 of 3, what's it equal to? The other way of sort of reading it is saying 9 to what power is equal to 3? And you might be able to see a half and go to there right away. If not, we can go back to what we did before, change it to exponential form, get both bases the same, and solve. So now you have just evaluated 3 log 9 of 6 minus log 9 of 72 is a half. Part B, 2 log 4 of 6 minus 3 log 4 of 3 plus log 4 of 12. Try it, get it to be a single log, combine it, we'll put up the answers in the end and evaluate it. Slightly different in your simplifications. But first of all, you'd have log 4 of 6 squared minus log 4 of 3 cubed plus log 4 of 12. And some of you might already be skipping that step. Okay? Did anybody skip right to this at the beginning? Okay, you can start to see, oh, those just go in as exponents, and then what's positives in the numerator and what's negatives in the denominator. So if I was about to simplify this, on the top, I have 6 times 6 times 3 times 4, or 2 times 6, it won't matter. And on the bottom, I have 3 times 3 times 3. Choosing 3 times 4 allows you to cancel out those 3's right away. You could expand the 6 even more and do 3 times 2 if you wanted to, or you could just say to yourself, I know that 6 divided by 3 is 2. 6 divided by 3 is 2. What do I have left? Every time something is simplified in a fraction, there's a 1 left. So on the bottom, we're going to have 1. And on the top, we have 2 times 2 times 4, which is just 16. And so you have log 4 of 16. And this is one where I'd say to yourself, before you change it to exponential form, look at it and say, 4 to what power is 16? Because logs solve for exponents. 4 to the power 2 is 16. So I didn't even have to change it to exponential form. This one worked out nice. Whereas the last one, I can definitely see going 9 to what power is 3? I'm not thinking of a half because I'm only thinking of whole numbers. That one might make more sense to switch. But this one, the answer will be 2.